So let's go through one improved Eulers by hand. We're going to use one of the ones we did in the Excel spreadsheet. Y prime is equal to x squared plus y squared. The initial value is at 0, 1. We're trying to find y of 0.5, and I'm going to use a step size of 0.1 just because this is going to get a little tedious. So our x value, our first one's 0. The first y value is 1. We're going up by 0.1s. So there's our x. That's the easy one. Everything else is a little bit more interesting. I'm going to move this value over here. So we've got to find y star first. And remember, we're not going to have anything in here. So the formula for y star is, I'll write it down here. Y star of n plus 1 is equal to y sub n plus h f of x sub n y sub n. So it's going to take that previous y value, which was 1. It's going to take that step size of 0.1, and then it's going to evaluate that differential equation at the previous xy. So we're going to get 1.1. So then we have to find this y value. So we're really going to have to bounce back and forth between finding the y star, then finding y, then finding y star, and then finding y. And you'll see why it's so much better to do this in Excel than to try to do this by hand. So to find the y value, our y sub n plus 1 is equal to y sub n plus h times f sub x n y sub n plus f of x of n plus 1 y star of n plus 1 over 2. And we said we were going to tweak that formula a little bit. And instead of dividing that by 2, I'm going to divide that h by 2, and I'm going to multiply it by that sum. Just to make the computations a little bit nicer to write out, both in Excel and by hand. So to find this guy, y sub n, that's our previous y. Our h value is 0.1, and we're dividing that by 2. And then we're going to evaluate that differential equation at the last xy. And then we're going to evaluate the differential equation at the current x and the current y star. So in Excel, I put parentheses around this. Those parentheses are unnecessary, but it kind of helps to keep the grouping so you can visually see what's going on. So I got 1.111. So now we have that, we can go back to this y star value and we can find it. So it says it's the previous y plus the h times the differential equation evaluated at the previous xy. So I got 1.2354321. So then this guy, using that y sub n plus 1 formula, is that last y plus h over 2 times It says it's the previous x, y in the differential equation. Previous x is 0.1. Previous y is 1.111. Plus the current x and the current y star in the differential equation. So I'm going to change my color so I can see it. 1.25153067 So then to find this guy, we're going to have to use that one. You can see already how tedious this is going to be. We can also take that value and we can store it in our calculator as some x. But if I'm writing this out so you can see what's going on, there's not really a shortcut here. So it's the last y sub n plus the step size times the last x squared plus the last y squared. So I got 1.412163576. So then this x value would be the last y plus the step size times the last x squared plus the last y squared plus the current x squared plus the current y star squared. So I got 1.436057 and some change. This is 423. So then the next y would be that number. When you're typing it in, keep all the decimal places. I'm going to have to abbreviate it here. Plus step size times the last x value plus that last y value. Squaring those individually because we're subbing it into the differential equation. So we got that. So then to find that y, we can use this formula. It says it's that last y plus step size divided by n times. And then we're evaluating the differential equation at that last xy. And then at the current x and y star. I got 1.688007332. So then last iteration, going back to that y star. I got 1.988944207. So then using this information into this for that very last iteration, this is going to be 1.688. Make sure you're using all the decimal places if you're doing this by hand. Step size over 2 times. We're evaluating at the last xy. And then we're evaluating at the current xy star. So I got 2.048770723, which is the same thing that I got on Excel. So that's using improved Euler method, solving it by hand. Good times, right? So as you can see, if we can use technology to help us do this, it's going to make our lives so much easier. The same thing is going to be true with Runge-Cut of 4, RK4 method. We are not going to do one of those by hand. I'm going to show you how to do that exclusively in Excel because there's, 4 or 5 6 different moving parts there. We've got that X that's changing. We've got a K1, K2, K3, K4, and then Y sub n.